Refrigerant recovery can be one of the most time-consuming parts of servicing an ACR system, but with a good understanding of the equipment and methods used, you can make it easy to do fast refrigerant recovery. We'll start by taking a look at the basic equipment that you're using. You're working with your hoses, your manifold, your recovery machine, and your cylinder, but there's some other details that are important for safety and for speed. With the refrigerant hoses, you want to make sure that you're using large 3/8 diameter hoses, not these little 1/4 inch hoses. These are great for charging because they restrict flow, but with recovery, they get in your way. So start with a 3/8 diameter hose, such as this short length, which reduces any lost refrigerant between the recovery machine and the cylinder, and still has 1/4 inch fittings, since that's what we're working with in most cases. The rating on the cylinder matters as well. For example, if you're working with R410A, you don't just need a 4BA rated refrigerant tank, you actually need a 4BA 400 rating. This means it's got a 400 PSI working pressure. Make sure that you're using a recovery cylinder that is rated specifically for the refrigerant that you're working with. Beyond just the rating of the cylinder for its working pressure, the capacity of the cylinder matters as well. You want to only fill a cylinder no more than 80% full. This helps reduce the risk of explosions or venting. When working with a new recovery cylinder, you want to make sure that it's been pulled into a vacuum before adding the first bit of refrigerant. In fact, many cases when you first get a new refrigerant cylinder, it's not actually going to be in a vacuum, sometimes even holding positive pressure, maybe with a dry nitrogen charge, and there could be other contaminants in the cylinder. So make sure that you've first evacuated the cylinder deep, below 500 microns with a vacuum pump to reduce any non-condensables or moisture. When working with a cylinder that already has refrigerant in it, make sure it's the same refrigerant that you're pulling out of the system. You don't want to mix refrigerant, otherwise you won't be able to get it reclaimed. An important part of refrigerant recovery is making sure that your recovery cylinder is fully evacuated and free of non-condensables and moisture before adding the first drop of refrigerant. This brand new cylinder was already at atmospheric pressure when we first hooked up the vacuum cage. Obviously it wasn't evacuated, it was not ready for use. So we hooked up our vacuum pump and pulled down a deep vacuum. We're making sure that we have a nice stable vacuum on the cylinder. But take a look at the TES8's TESM oil cartridge. This shows contamination that you've pulled out of a system, and as you can see in this cartridge, compared to a brand new cartridge, this was clean oil. We've pulled something out of the cylinder. So just a reminder, make sure that you use a vacuum pump to pull your cylinder into a deep vacuum before doing your next refrigerant recovery. With the first step done of making sure that your equipment is rated not only for the refrigerant but for flow, now we want to make sure that we're connecting it for flow. And that means following through all of the connections from the system through the recovery machine to the cylinder. As you'll see, we're going to hook up to both sides of the system using valve core removal tools to remove the Schrader. That access valve core blocks 90% of the fitting. It's a metering device that, as you'll see in our other video, will actually increase both the temperature and pressure of the cylinder during recovery and slow everything down. So before performing fast recovery, we will remove those access valve cores using a valve core removal tool. The traditional method of recovery would then connect both sides through the manifold and 3/8 hoses to the recovery machine. You can also perform direct recovery without a manifold, a method we describe in our refrigerant recovery without a manifold video. A recovery machine will only push refrigerant up to the top of its piston. That means everything from its output channel to the recovery cylinder will always have refrigerant. That means you want to make sure that the hose has the smallest volume possible without restricting the flow, such as this 3-foot 3/8 hose with 1/4 inch fittings. And then we'll want to make sure that we're connecting to the vapor port. This is the unrestricted port of the cylinder. If you're pumping in through the liquid port, you're actually going through a tube that goes to the bottom of the tank. This tube is typically a smaller diameter and greatly restricts the flow. And if you're ever hearing a knocking or rattling sound in the recovery machine, it's usually because you have a restriction somewhere on the output side that is causing the pressure inside the machine to jump around. But now as we've got everything connected, we have to purge the lines of air, non-condensables. You don't want to add non-condensables because it always slows things down. But you also have to make sure that you're purging in a way that is compliant with EPA de minimis rules. What that means is that you are purging carefully, just enough to remove air from the lines. In this case, we've hooked up a traditional recovery method, which is connecting from both sides, through a manifold, and through a hose, through a filter dryer, and into the recovery machine. One key thing to pay attention to with the filter dryer is that the flow is going in the direction that is marked with an arrow on the dryer itself. To do this with maximum control, we're going to use a manifold that has an additional port to the same connection. This allows us to purge just the side of the hose one side at a time before purging through the recovery machine. So purging one line at a time each to the manifold and then using one of those channels to purge the line through the recovery machine makes sure that you always have one direction of flow in that purge. So in this case, we're going to be purging the high liquid side, and I have a port here that I can keep cracked open, and I'll be shutting as soon as I see refrigerant, smell, or see any sign of refrigerant reaching this line. Make sure that the valve is fully closed, and now, being prepared to fully shut, I will crack the valve there. And making sure that I close at the moment that I have any belief that I have refrigerant fully reaching that point. It's a 6-foot hose, and with a 3/8, there's a little volume, so it can take a little bit longer than just a brief second. But you do want to make sure that you are wearing good hand protection just in case it takes you that extra second to close the port. Now we have refrigerant purged all the way up to the manifold. I'm going to need to open one of those lines and get it purged through the recovery machine. Here's one advantage of using our valve core removal tools. They have a side port that we can actually keep open and have close very quickly as soon as that sign of refrigerant reaches that port. Now I'm going through 2 6-foot lines, and this could take more than just a brief moment. We've now purged refrigerant all the way through to the recovery machine. The final purge is the hose to the recovery cylinder. Again, you can use the same tip of the ball valve with a side port, using that as your low loss fitting on the hose. It has the added advantage of being a full flow valve, no restrictive valves like the auto shut off or quick disconnect valves. And that means you have full unrestricted flow, and plus you can use that side port to make the purge very quick and very easy. Now you've got full flow going to the tank, make sure you're hooked up to the vapor port. It's open straight to the top of the tank, as opposed to the liquid port, which uses a 1/4-inch dip tube going all the way to the bottom. That's a huge restriction that you just don't need. But since you're going to be pulling the liquid out of the system first in an ideal process, you want to fill that liquid from the bottom up. How do we do that? We flip the tank. I'm going to open up the tank, which is going to suck in a little bit of the refrigerant from the hose that I've already purged out. When flipping the tank, make sure you rotate it in a direction that will tighten the fitting. You want to make sure that you're not loosening the fitting and possibly getting refrigerant in your face, as fun as that might be. So now we've got the tank upside down. We're ready to start once we open all the valves and get things moving. We'll start by opening the liquid port from the system, making sure that's fully ready to go. And just before we start the recovery, we're going to open the valves. Everything's ready to go. It should begin flowing to the tank automatically. You'll make sure that you've tared your refrigerant scale so you can monitor the whole process. Now, it's time to begin recovering. So you notice that while we're moving refrigerant pretty quick, I've already moved 2 pounds in just a few seconds. The machine is not noisy. That's because we've removed all the restrictions. Now, as you get the liquid out of the system, pretty soon you're going to have vapor. That's the point at which refrigerant recovery starts heating up the tank, at least a little bit. You can do a number of things, such as getting an ice bucket, throwing a wet towel and blowing a fan on it, but you know what's really easy? Just grab the G5 and blow its fan. You can obviously have that sit on a stool or something, and have that fan pull air around the cylinder. That helps dissipate a lot of extra heat over just ambient air. However, overall, because we've taken this process and opened it up, the tank's going to stay a lot cooler than you might expect. Now, as you're watching your gauges, you've started with the liquid side, and at a certain point, depending on the size of the system, you're going to open up the vapor port. This allows you to pull from both sides of the system at the same time to fully complete the process. When recovering with the method where you turn the recovery cylinder upside down, you got to understand when to turn it back. And that's because you want to make sure that the hose coming from the recovery machine to the cylinder is filled only with vapor. Keep in mind, a recovery machine can only push refrigerant as far as the top of its piston, so there will always be some amount of refrigerant in this output hose. Ideally, that's vapor, so it has lower density, and that greatly reduces any refrigerant lost in the process. So you'll be watching for the pressures to be between 75 and 100 psi on your input side before rotating the tank. You can also use a sight glass to be sure that liquid is fully done, because your idea again is to make sure it's only vapor. When you rotate the tank back to the right side up, make sure again that you rotate in a direction that would tighten the fitting. Again, this is for safety. You do not want those fittings coming loose during the process. The recovery process is complete when you have pulled the system down to the required EPA level of either 10 or 15 inches of mercury, depending on the size and type of system and refrigerant. In this case, we're already at 12 inches of mercury. We've moved 10 pounds of refrigerant in just a matter of minutes by opening up the flow and making sure that the process can go smoothly. The tank has stayed cool, pressures have stayed low. Now, to shut off the recovery machine, you'll first make sure you have valved off the valves of the system, watching all the gauges to show that you have pulled a nice deep vacuum on your input line. And then you'll want to make sure that you have shut your output valve at the same time as you turn off the machine. This is to make sure you don't have any significant back pressure from the tank pushing refrigerant back up to the hoses. And by quickly shutting all the valves involved, you're making sure you have the minimum amount of refrigerant in the hose to meet EPA de minimis requirements, but your recovery is done. We've removed our valve cores with our valve core removal tools, so we're ready to use both ports. Now we'll want to connect the low side to the high side so that when we're done recovering liquid, we can switch over to recover vapor from both sides of the system. The side ports on our valve core removal tool make this easy when you can get them connected, when there's room. So first, we'll want to connect a third valve core removal tool to the side port on the liquid side. We can also use the side port for the third tool to connect a digital compound gauge in advance. This will help reduce any added refrigerant loss, because what we're going to do is actually remove the valve core from the side port, since that's restricting flow here. Now we can connect a short length of 3/8 hose from the low side to the third valve core removal tool, and we'll perform a brief air purge from the hose. And an easy way to do this is to get the hose mostly fully seated, back off, so that as soon as I get this cracked open, I will actually be able to close the fitting very quickly. Use the vapor side, which I've got a helpful ball valve here for. Use the vapor side to reduce how much refrigerant you're using to perform this purge. As always, make sure that you are wearing hand and eye protection when performing a line purge, because you are going to potentially release a small amount of refrigerant to the atmosphere. Now all that's left here is to connect one other hose from this liquid port valve core removal tool to your recovery machine. From here, you will proceed the same way you will with the direct connection method, purging the lines all the way through the hose to the recovery machine to the cylinder, the same as in our other video. Recovery without a manifold using 3 valve core removal tools, as shown here, reduces the total added line set and ensures the full flow and fastest possible recovery speeds. Try this out on your next recovery and let us know in your feedback and comments whether this helped you reduce your overall job time.